Okay, we are set. Hello everybody, good afternoon. In this presentation, I'm going to show you how the Cyprus Institute's research team managed to lower the CO2 emissions considerably in the smart urban Isle. In fact, just by using smart renovation methods and the employment of renewable energy sources. Cities, they have a lot of advantages. That's why we prefer them and we live in them. But at the same time, they are responsible for a lot of global emissions. And with the rapid urbanization, we already, half of the population, the global population, lives in cities. Sustainability is very crucial, and we must do something about it. This is exactly what the project Smart Urban Isle, SUI, aimed to do, to lower the CO2 emissions by reducing the energy consumption within areas which we call urban isles. They are within the infrastructure of the city, and they comprise from 12 to, could comprise from 12 to 1,000 buildings. And they make, they take advantage of all the available sources on the site, all the various functions, and the storage solutions and the scale of the site to do that. That is, to move forward with the energy savings. So this is the methodology we followed in order to achieve that. We investigated the site, the energy consumption of the site, and the CO2 emissions, which are related to the energy and to the mobility. And in one coastal city of Cyprus called Limassol, most of you know it. We identified the shortcomings from this investigation, and we developed several scenarios in order to improve the energy efficiency and hence lower the CO2 emissions. The scenarios involved bioclimatic measures, energy efficient measures. They involve the mobility reformation, alternative methods that is, and the employment of renewable energy sources. We evaluated the results of this and we reached to some conclusions. So this is the urban isle we have chosen. It's in the center of Limassol, the built-up area of Limassol. It has 12 buildings, non-residential buildings, and it has about 5,400 square meters of area. We have chosen one of the buildings, which it's a university building, Cyprus University of Technology building. It's an administration building, but it includes other functions as well. And we did an in-depth analysis and studies of this in energy and the lowering of the CO2 emissions. These are the results in one slide. We did surveys about the comfort. We found out we had sound acoustic comfort as well as visual comfort, but the thermal comfort is suffering in the ground and in the mezzanine floors. As far as the energy consumption is concerned, we use two simulation tools, the ISBM, which is the formal government tool for the certification of the buildings, and we also use the design builder which is the most popular and the most dynamic nowadays tool for the investigation of the energy in the building. And we use also the bills, the actual bills of the building, and we base, in fact, our study on the bills, on the consumption, which amounts to 116 kilowatt hours per square meter yearly, and we use this as the basis. And also the emissions, which come to 82 kilograms of CO2 emissions yearly. We also investigated the energy on the rest of the buildings of the site, and this we found out that it comes to about around 750 megawatt hours yearly. That is 220 kilowatt hours per square meter yearly. So keep these 220 in mind to compare it at the end. As far as the mobility is concerned, Limassol, as all the cities in Cyprus, they are characterized by their automobile use, and also from the study we found that the automobile prevails as far as the passenger and the kilometers they cover is concerned. So these are the results in a snap. And we also made a survey and on the visitors and on the occupants of the site and the mode of transportation they are using, and this concluded that the mobility on the urban island has CO2 emissions which share more than 50% over the total emissions of the urban isle that we study. The remaining of the emissions are due to the building's energy consumption. So we also investigated the potential of the renewable energy on the site, which we found that there is 454 megawatt hours per year for electricity, for PV, and 2,216 megawatt hours yearly for solar thermal. So obviously we have plenty of it and we have to make use of it. This is the study, the whole picture of the urban isle as far as the building is concerned, that we did the study in depth, which has emissions of 80 kilograms per square meter. The area, the built area, which has 142 kilograms of CO2 emissions per square meter, and the mobility and lighting, which comes to 132 kilograms of CO2 emissions yearly. So this is 676 kilowatt hours per square meter, the energy consumption of the whole urban isle, and 251 kilograms of CO2 emissions per square meters for the whole urban isle. So the summary of these shortcomings and the potentials is that the energy performance, there are energy performance deficiencies in the buildings in all categories and at all levels, that is at the buildings, at the urban level, on the built environment, on the mobility, and on every aspect of the urban isle. And there is high energy consumption of the buildings, and this is mainly due to the poor envelope, energy performance of the envelope of the buildings. There is minimum on-site renewable energy exploitation although there is very high potential for this, and the mobility is responsible for the 50% of the total CO2 emissions. Then we tried to improve this situation. We first of the building that we studied in depth. We developed 3 scenarios. The one scenario was the business as usual scenario. The other one was the zero energy building scenario according to the existing legislation, which focuses mostly on insulation. That is, we have presently in Cyprus. But I present here the results of the smart zero energy scenario, which is a scenario which we developed after examining individually all the effective, or what we thought they are effective measures, interventions that we could do in the building. And in terms of cost effectiveness, in fact. And we concluded to this which we called smart urban, smart zero energy building scenario, in which we replace all the air conditioning systems, we replace all the lighting with better one, improved ones, obviously. We put control of temperature in the buildings, cool paint on the roof. We added a window shading film. And then in the mobility, we found out that the reformation is needed. In fact, we have to increase the public transport and decrease the other modes of transportation. The building renovation is needed with the employment of mini networks and with light renovation of the buildings. And what is happening? You can see it. So the mini network, in fact, is 100% energy efficient yearly. The results, these are the results. We managed to reduce the energy by more than 30% for the whole aisle and more than 40% for the reduction of the emissions. So the conclusion is that there is we can have high energy savings, and so the national legislations should take into consideration other modes besides insulation. We have high mobility CO2 emissions, and reformation is needed for the mobility to tackle these CO2 emissions, to increase the public transport and decrease the automobile use. Also, the renewable energy sources are imperative in order to reduce the CO2 emissions and move towards sustainable cities. Thank you very much.